Hi everyone, thank you so much for joining the Avid CNC live stream. I'm Sammy and I'm really excited to share this project with you today. As you know, recently I've had this Benchtop Pro machine here in my home studio, and I really needed a way a place to put it and something that was functional and really worked well for my needs. And I really think that workbenches are something that we all need in all different aspects of our lives and our making and in different parts of the shop. So I really wanted to make something that I would be able to utilize and in those different aspects and try to make that same design really work for all those different needs. So thanks everyone who's tuning in, and yeah, let us know where you're tuning in from. Thanks everyone for being here. Corey's over here in the chat. So yeah, I'm thrilled to get to share this project with you. I tried to make this project so that if you used a variety of different kinds of CAD CAM programs, or if you even wanted to just make it with some simple power tools, it'll be really easy to do that way as well. But if you're like me, I really like to use the machine to do simple pockets and that sort of thing. Cuts a lot of time out. Yeah, one definitely can never have enough workbench space for sure. So I certainly need to build several more of these for my basement shop and the new media studio here we're building out so we can make a lot more videos for you, and I certainly need a couple more workbenches there as well. So the different, let me just show you, let's go ahead and I'm first going to show you this. This is the, okay, yeah, so here's my render, and then here is an image of the workbench here behind me with the Benchtop machine on top of it and installed with the controllers and the cables. I really tried to be thoughtful about how that machine was placed and all the components that you want to go with that. And this is really customizable, so you can add different features that you like, if it's additional shelving or drawers. I've tried to plan for several different places for the cables to be stored in, if you'd like to make sure that those are well and tucked away. And you can of course use this workbench for your tabletop drill press, sanders, whatever you need them for. So the different files that we are going to be going through today is, first we'll have a Fusion 360 tutorial on how to create this design. We'll talk a little bit about parametric modeling, and I'll go through the whole tutorial on how to model this. After that, we'll come back in and go through the Vcarve files I've made for this. So I've made two Vcarve files. One is for the legs on this workbench, and then one is for all of the plywood components, which would be the top and the vertical stretchers, or the stretchers that go across the front and front to back as well. I'm calling those the side stretchers. So really you only need a couple 4x4s and one sheet of plywood to make this project. You can always add in different shelves and whatever you like to customize it, and depending on the need of the workbench. So let me just show you a little video of zooming in on the parts of the workbench and the different features of it. So here's how it kind of sits in my space. I have a couple of lap joints going on, so it's pretty strong and very easy to assemble. This is made for the Benchtop Pro 2424, so the 2x2. You can expand it to meet the needs of the larger machine as well. And I have a shelf here where I have my little vacuum, my little air compressor, and my pneumatic nail gun. Here's my little drawer from IKEA I just screwed on super quick. It's this kind of flat pack metal drawer for all my little router bits and everything. And yeah, so I thought this was pretty simple design, pretty quick to build. And underneath here, yeah, you can see the plugs on the back wall here. I have my air hose in the middle and some storage between the legs for the wires. The controllers are hung by a French cleat. You can really hang them however you prefer. You can see here is where I mounted the emergency stop, and a kind of close up of the half flap where I also glued on some cork feet as well. Okay, so I'm gonna close that video. Now, let me just show you very briefly the different files I'll have available for you in the description below. So one that I think is pretty important is this is the PDF plans that I've made in the drawing workspace in Fusion 360. So I didn't include a tutorial on how to use the drawing space for this project, but I have linked some excellent tutorials on how to use the drawing workspace. You can download this PDF, whether you're using Vcarve to make the components or Fusion. This will definitely help you in assembling it and kind of getting your mind around how to actually assemble the whole machine. So it's pretty neat. I threw in the little render here, a couple different views, a breakdown of the different parts that you need to fabricate and assemble. You have some the dimensions, the front view, right side view. Here's a breakdown of the workbench legs. So it kind of shows you here we have a half flap. And I guess this, this is kind of a dado half flap situation. And kind of demonstrating on how the side stretchers and the front and back stretchers are assembled with the whole workbench. And these are very simple. So if you have a table saw, you can just rip them down. But I also have the Vcarve file that has the them already drawn out. So if you just want to throw the plywood on the machine and cut them out, you can certainly do that. It's definitely what I would do. So, and there's the workbench top. You can make this out of whatever you like. I happen to have a 1-inch piece of MDF. You can fit on the plywood sheet as well. We have two different shelves. We have the left shelf over here, which was where I had my little air compressor and my vacuum. On this right side, this is where the controllers will be housed. So you can put all the cables between these two legs, or you can hide them underneath these drawers. So I would glue or fix this bottom shelf to the cross stretchers, and then maybe the top one is just pressure fit or magnets or something, so you can lift it up and the cables can just sit underneath there, and you can lift in the top up when you need to access them. So here's the different shelf components as well. Right, so I have that PDF available for you. And then here is just a brief look at what our Vcarve files look like. So here is the file for the workbench leg in Vcarve Pro. Here's the 3D view. We'll preview this toolpath here for the workbench leg. And then here is our file for the stretchers and the tabletop in Vcarve. You can also notice here I added a little circle for the cables to pass through on the tabletop here. I actually forgot to add that in the Fusion. Well, I added that to the Fusion file most recently, but I forgot to go over that in the tutorial. So maybe I'll touch back on that at the end. So if you'll have any questions throughout the Fusion tutorial, I'll just get to those at the very end here. And then we'll go back into these Vcarve files. So here we go. We're going to jump into our Fusion tutorial. And if you are watching this live, we'll get back to the questions at the end. And if you're watching this later on, I'll have all those timestamps for you to kind of jump to the parts that might be more interesting for you. Okay, here we go. Okay, so here we are in Fusion 360, and we are going to create our Benchtop Pro Fusion parametric model. If you aren't into using Fusion, or you just don't use Fusion 360, that's okay. I will have our PDF plans and DXF files, and we'll also go into the Vcarve Pro CAD CAM for this project as well. It's relatively simple to actually fabricate, so if you're not so interested in the design aspect of this, you can kind of skip forward later on. Okay, so here we go. We are in Fusion and we're creating a new design. So in the description below, I have listed a video that was kind of really explains parametric modeling a little bit deeper, and we go over the different dimensions and how to accomplish that. I'm going to go through this pretty simply and try to explain why I would like to use it for this particular project now. In the description, you'll also find a PDF that includes all of the parameters that I set up for this project. So if you can't necessarily see it super well on the screen, I will have a chart for you in the description for you to check out later on. Okay. All right. So we're going to create a new design, and I like to start out by making these parameters. These are so that I can adjust the dimensions as I go, rather than being so tied down to specific dimensions before I might have even determined what material I'm using and that sort of thing. Also, it makes the life of this particular model exist in a much more full way. So I want to create a series of workbenches, for example, for my new shop, and I need them to be all sorts of different dimensions, but I generally want them to have the same look and joinery style and make them kind of really adapt. So having a parametric model for a workbench makes a lot of sense. We'll go into change parameters here, and I'm just going to go ahead and enter in all the dimensions and try to predict what I'm going to need. So I want to make this with 4x4 legs. If you like to use 2x4s or whatever, that is fine too. I'm going to call this leg width. Make these 3.5 inches. Okay. Then I'm going to say leg spacing. So I want this to be the leg offset, how much space is between those legs. So I will say this is going to be 40 inches. Okay. So how high do we want the legs to be? Let's say leg height is 30 inches. So this is super helpful if you have different things in the shop that need to be higher or lower. If you have a drill press that goes on a bench, you might want it to be higher or lower. If you work in a chair, you might like that to be higher or lower. Whatever your particular needs are, you can adjust this model. So say OK for leg height. I also know I want my cross braces to just be ripped out of plywood. If you have a particular hardwood you like to use, that's really fine too. Let's call this plywood thickness. Call this 0.75 inches. Now I want to do my top dimension. So we'll call this top width. I'll make this 45 inches, and I'm going to make mine a square, so I'll use the top width is going to be the same as the top depth. If you have a 2x3 Benchtop Pro, you might want to make it longer. Check the PDFs. I've also linked in the description to kind of show you the external dimensions of those machines. So I know that the 2x2 Benchtop Pro will fit really perfectly on a 45 by 45 inch top, which I have set up right here. So say OK. Say top thickness. So I'm going to make my top thickness out of 1 inch MDF because that's just what I have around. So we'll say OK. Let's start with that for now and say OK. So there's a couple different ways we can start this model. Do we start with the legs or the top? I think let's start with the top. We'll create a sketch. I'm going to sketch on the XY plane here. And I'm going to create a rectangle. We'll do a center rectangle so I can kind of start from the center and work my way out. And here I'm going to type in my dimensions, which is top width by top width. So now when I hit enter, it'll confirm that rectangle. These are parametric, so if I open my parameters here and I want to change the top dimensions, it'll automatically adjust. We'll change that back to 45. Perfect. So you can see already how helpful it is to enter all those parameters early on. So now I could think about the dimensions that I like for my leg spacing, but I think I'll just allow this sketch to be the top. So we'll say finish sketch. I'll zoom out a bit here. I like to label my sketches, so I'll go ahead and name this top. We'll hit E for extrude and pull up on the arrow to extrude that rectangle. Now we can go ahead and type in top thickness. Hit enter to select. Great, and so now we already have our top there. Now I want to create a sketch that is referencing this particular bottom of this model because I want the legs, it to be sitting on the legs, so I think this is a good way to do it. Let's go ahead and create. I'm thinking there's one other dimension I'd like to add here to our parameters. Let's add a leg offset. So that's how far in I want the legs to sit from the edges of that top. So we'll make this so let's make that 2 inches. Okay, I think that will help with our initial drawing of the leg. So we'll go ahead and click OK. We're going to create a sketch, but instead of picking one of those 3 planes, we're going to pick the bottom plane of this tabletop. We can hide the body of the top here so that we can just kind of focus in on our sketch. The first thing I'm going to do is create an offset and select the outside of my rectangle and type in minus leg offset and hit enter. So now I kind of have this to work with. I know the 4 corners of where I want my legs to go. So I will go ahead and create some rectangles here that are the dimensions I would like the legs to be. So I'll call these leg width. Hit tab, leg width. Okay, so I could draw 4 different legs there in the different corners. I could pattern those as well, but I'm going to make these individual rectangles so that I don't have them be linked together. So when you make a pattern, those can be linked together, so you won't be able to edit those parts individually. Hit R for rectangle. Great, so now we have our 4 different legs here that we have set up. Now we want to set 2 more legs so that we have a panel to hang our controllers on. So we can create a rectangle here. We'll just place it anywhere. Great, so now we can go ahead and set a dimension for this leg to be offset from this leg. You can reference whichever side that you would like. I just know that I want 12 inches between these 2 parts. So I'll just hit the letter D for dimension, select these 2 lines. Now I can type in a dimension here. I'm going to type in 12 and hit enter. Awesome, so now I know that the spacing is 12 inches between the 2. Do this again. And we can make this parametric as well so that they will adjust. So you can see I've set these dimensions already, but that doesn't mean we can't go ahead and change them. So if I go to the Modify panel and change parameters, I can say this could be the controller legs spacing. And we'll make this, say, 10 inches if you wanted to make it 10 instead. Click OK. So we'll just double click on this dimension and type in controller and hit enter. And you can see it automatically adjusts. Okay, we'll finish sketch. So now we have our 6 different legs. I'm going to go ahead and extrude these. We'll pull down on the arrow and type in leg height, right? So now we have 6 different legs, and it can say new body or new component. Let's say new component. That's the golden rule after all, and say OK. So now we have our different legs here. So we have a couple different things we need to make in order for these to really work well. So the first thing I'm going to do is to create some cross beams that go across the front 3 legs. I'm going to create a new sketch, but first I'm going to make sure to label all of these. I'll call these legs. I'll call this sketch the leg layout. Okay, it's good to name all of your parts and layers really well. This is good organization. So I'll create a sketch, and instead of selecting one of these 3 here, I'm going to select the front leg. I'll create a 2-point rectangle and select that top corner of the leg and drag my rectangle out. Here I can type in those dimensions. I'm going to make this the leg width. You know, might as well rip down my plywood cross beams to match the width of the legs. Okay, and then my other dimension here, I can set this to be, I could snap it to here, or I could just type in top width. Okay, so that's going to be overshot a little bit. So what is the difference between those 2 outside legs? I'm going to do subtract offset times 2. So you can see here I've subtracted 4 inches from that overshot because I know it's offset 2 inches on either side, so I'm compensating for that, and hit enter. So I'll just create the same one down here and type that in, leg width, and we'll make this the top width minus parentheses offset star 2. Okay, so now I have that cross beam, but I know I want this to be offset so my legs can stick out a little bit more than this cross beam because I don't want the cross beam to sit straight on the floor. So I'll hit the letter D for dimension. Select the bottom of the leg and the bottom of that cross beam here. I can make that any dimension I feel like. I'll make that 1.5 inch, for example. Okay. Great, so now we have our cross beams and we'll finish our sketch there. So now we want to extrude and subtract into these 3 front legs. So I'll hit the letter E and select my rectangles. So now I'm going to pull this arrow back into my legs. If I pull it this way, you can see it's a positive. If I cut into it, you can see that it's subtracting. I can pull it that direction too and change it to a join or a new body, but what we're going to do is we'll cut first. So we'll subtract the plywood thickness here, so we can make some half flaps over here and some dados over here, and click OK. Right? So we have our joinery is starting to come together. And now I need to create the actual positives, the cross beams that are going to go across. So we'll rename the sketch called front stretchers. Okay, turn that sketch back on. We'll hit the letter E for extrude again. select those rectangles, but this time we're going to create a positive. If I do subtract plywood thickness, you can see it's not interfering with those anymore, so the red kind of goes away. But we don't want them to join because these are separate pieces. We'll say create a new component and say OK. So you can see here, if I hide my sketches, I can rename this front stretcher, right? Turn this off and on, and you can see that those are fit perfectly. You can also go to you can also go to inspect and go down to component color, so you can see how those kind of fit together with the joinery. It can be helpful. So maybe we'll work in this mode for a moment here. So I want these to be mirrored on this other side. I could make a copy of this and mirror it. So where are we going to mirror across? We can, because we've modeled from the center point of this point here, we can mirror across here, or we can create a mid-plane. So let me just show you how to do a mid-plane. This one will work as well. That is the XZ plane, because we've modeled from the center out. But say, for example, you haven't done that and you need to create a plane to mirror across. We'll go to construction plane and go to mid plane. So we'll select the two planes we want to create one between. I'll select the front of the front leg and the back of the back leg. So it kind of creates a rectangle here. Okay, say OK. We can grab those corners of it and pull it out here. So it's just a little visually more. You can see that's going right down the middle. Okay, you can also see that it's the same, it's pretty much the same plane as your XZ plane. So I'm going to go ahead and show you a different way of subtracting from the legs. So I will, instead of mirroring feature, I'm going to mirror these components, which are these two front stretchers. And the mirror plane I'll select is this mid plane, and we'll say OK. So you can see that our front stretchers are mirrored across that. So now we can go ahead and hide our construction plane. But if I zoom in here, you can see that we haven't actually subtracted from these legs. So it's just two bodies, or two components kind of interacting with each other in the model. So what we're going to do is we will do a Boolean instead. So if you come up here to combine, we can select our target body and our tool bodies. We can either join them or we can cut. So we'll say cut and keep tools. Say OK. So now when we hide our mirrored front stretchers, you can see that we've subtracted from those. So let's go ahead and do this again. Awesome. So now we have our back legs here that have those half laps cut into them. Great. So now how are we going to connect these two front and back half of our workbench? Let's go ahead and create a new sketch here. And we have a couple options. So I know that I want to make some cross pieces that go between on the inside of the legs on each set. So I'll start with this side. We'll say select that, OK. But I'm actually going to just hide and turn off all of our bodies and components, so then we can really focus on what we want to look at, right? We want to turn on our front left and back left legs here. So I know I have a piece joining here and one there. So I'm going to create another rectangle and just snap between those 2 points. So you can see I can't snap on this side because this plane is not included in our sketch reference. So I'm going to cancel, right-click cancel, and I'll select that plane. So we'll go to Create, Project, Include, and we'll project this. We have the selected geometry, and we'll say OK. So now you can see we can reference that vector as well as we can reference this one. So we'll make a rectangle here, snap, and snap. Awesome. So those dimensions were selected there. So those are snapped to those points. So those should adjust as we go. Let's make another rectangle here and here. Okay, so we have left side, front to back stretchers. Okay, finish sketch. We'll call these side stretchers. Okay. Now we can go ahead and extrude these as well. So I'm going to hit E for extrude, select those boxes. But I'm not going to make this a joint in terms of cutting into it. We're just going to screw it on because those are going to be hidden screws. You want people to see them. It's kind of nice to kind of make that as seamless as possible, but it's underneath the whole thing, so it should be there for more support and less aesthetics. We'll create a new component and we'll say the distance is ply. Okay, and click OK. So now we have two left and right cross members. Let's turn back on our other components here. Awesome, so we are moving along. So I want to make sure these are copied on this side, but I'd prefer for them to be on the inside of this leg, so I could mirror that across, or I could make a move and copy. Let's see, let's mirror these ones. So I'll create a mirror, select my component, select my mirror plane. I know that I am drawing on this center of this origin, so it should automatically snap to those inside of the right legs. So we'll say OK. Great, so I have another set here. And now I want, instead of, let's see, what are my options here? I could do the same thing for these as well. So instead we're going to do, I could do a solid panel in between, which I think would look best. On mine here, I didn't actually do that, but I do think it would be very useful. I also want to put a panel across here to hide the electronics or the cables, put a panel across here to make that have some extra support. So let's go ahead and make those sketches here. So I'll create a sketch and do that on the inside of this leg here. We're going to go ahead and hide all of our other components just to kind of make it a little bit easier to see. Okay, so we're going to do this project include again. So we'll do, select that vector, create project include, project, and click OK. So now we have our two middle legs and the front and the back. Just to make these rectangles real quick here. So I could do this one across and one across here so that I know that's the same components as we have existing already. I'm going to do the French cleat just to kind of show you what I did. I made these about 2 inches tall. Okay, one rectangle there and one more rectangle a few inches down. I don't have the exact dimensions of how high those cleats are, but we can measure those and adjust later on. Okay, so we'll finish this sketch. And I'm going to extrude these plywood thickness. And we'll make these into a new component and click OK. So we have our new components here. So this is a cross beam, this is a cross beam. This is actually going to be a little cleat. So I can make a sketch here on the end. Draw a little diagonal here. from there to there. If I zoom in, if I hit the letter D for dimension, I can set the dimension of the length, but if I pull up and touch this other line here, I can set this angle. So if I want this to be 45 degrees, I can do that and hit enter. Finish the sketch. If I hit E for extrude, I can cut that part. And so now I have a quick little French cleat that I can screw in and hang my boxes on. Okay, so now I have my panels. The reason for this strip is so that when I hang the French cleat on, the French cleat is mounted on the back of the controller, and then this kind of prevents the bottom of the controller from swinging back. Let's go ahead and turn on all of our other components again. So I know that I want to mirror this and this onto the other side so that my little shelves have plenty to sit on. And you know what, we actually need to create a mirror plane here. So I'm going to go to Construct, Mid Plane. I'm going to select the two different sides of our leg. And let's go ahead and turn our construction plane back on, hide our first one. And now the second one here, we can pull this out. Now we can go ahead and mirror those middle stretchers here. We're going to select we're going to actually select bodies instead of components, because these four were made together in one component, but we only want to mirror the top and bottom stretcher. Our mirror plane will be this one that we just made, and say OK. So I know it looks pretty busy right now, but I think that once you have all of the, it kind of all built and with the controller boxes on it, it will really not be too much. Awesome. So now I want to make those tops here for the shelf. So I'm going to go ahead and create a new sketch. And I'm going to select the top edge of my stretchers. And I'm going to actually make this sketch in 3 dimensions rather than 2, so you can really understand where that shelf is going. So let's go ahead and actually select some more surfaces to include. So I'm going to Shift select a couple different surfaces on those bottom stretchers. Awesome. So now I can create project and project that geometry. Okay. So now I really have a lot more to work with, some more to snap to. Okay. So we're going to create a new rectangle. And draw that. And you can draw this one over here. So you zoom in and see that this line actually didn't really snap to this leg here. So what I can do is kind of zoom out, and maybe I'll project this bottom leg to include that rectangle as well. So we'll project and include that bottom of the foot to that sketch. So now you can see that this rectangle is showing up. So now if I hide all of these bodies and everything, you can see how that foot really does show up. So now if I drag this over here, it can snap to that corner, and we're in business. So I'll go ahead and say finish sketch. So I know this looks really busy right now because of the cross beams, but we just need to make sure to select the right rectangles when we extrude. So I'll go ahead and hit E for extrude and select those boxes. Okay. And we're going to extrude this plywood thickness. And we'll make these into, they could just be new bodies, that's fine. And now when we turn everything else on, you can see how they sit on there nicely. So I've turned all these bodies and components back on. And And let's go ahead and view this without the component color cycling toggle. So we'll turn that off. So now we have everything's kind of gray again. If we also want to turn our top back on. So now we can kind of see the whole workbench. We'll go ahead and hit A for appearance, and we'll just find a nice wood to throw on there. I like the solid wood options. Go to the unfinished, something classic. Made mine out of pine, but really whatever you prefer. And we can go ahead and put these, drag and drop. Go ahead and drag this over to the whole model and say remove, because I've already applied it to the top, but so it thought it was kind of writing over that. You can see kind of how simple this kind of workbench is. You can definitely make this from some simple plans and adjust the design, add some drawers, throw in some more shelves. You can do a different kind of hanging system if you prefer. But that's kind of how you make that model. So we'll go ahead and go into the drawing workspace now. All right, well, that was the Fusion walkthrough tutorial. Sorry about that long video clip right there at the end. Let me go back into our screen share so I can kind of show you our different Vcarve files. So if you're a Vcarve user, let me know in the chat here. And if you have any more questions, I'll be sure to answer those before the end of this stream here. So let's look at this. Let's first look into the Vcarve leg files. So this was made just with very simple pocketing toolpath. Let's go into our layers first. So the way I like to organize my Vcarve files is by the different types of cut operations and then the different kinds of vectors that we'll be using. I also have a layer for my notes, which I find is very important, especially when I'm sharing my files with others, whether it's, my technician in the shop, if I'm a designer and I'm sending the file over to them in order to process, or if, I'm making a file and trying to share with you all. I want you to understand why I made certain choices, or what I might recommend, or the quantity of the parts. So here in my notes, this is the Benchtop Pro Workbench legs. You would want 6 quantity for this particular setup. These are the dimensions I used. The one difficulty here with using the Vcarve file versus the Fusion file is that the Fusion one is parametric. So if you want a different height, then you can just automatically update that in the parameter dimensions. Here you would just do that manually. You would just understand that if you don't want your legs to be 30 inches long, you can make those shorter as you like. The suggested material I used is, the 4x4s, kind of just what I had around. So you can make changes there as well. Let's look in these different lines. Here I have the green lines when I zoom in. That's the actual pocket where the joint is. But the blue lines here are what I'm going to be using, the vectors I'll be referencing for making that recess pocket. You can see here, I just want the router bit to overshoot the edge of that material, just in case, because 4x4s are really not that consistent, or they might have a little bit of a twist to them. Things like that. I want to make sure that the pocket is going to extend beyond the edges of the material, right? So this is for the bottom stretchers to sit in, and then over here is for that top half lap. So I kind of just overshoot that length as well. I just cut these down, the 4x4s on the miter saw, just to zip real quick. And the way I used the work holding, as I have some notes here, is that right in the middle here, you have a safe clamp area. So depending on your work holding setup, right, it might be different for your different kind of machine. This is a safer space to clamp to, but what I would recommend is for you to go into your material setup here and just check your rapid Z gap safe heights. So what are how high will the spindle lift up over your material in order to compensate for those that area where your clamps might be sitting. So do double check that, and you want to consider how high your Z-axis can go. It should be plenty. These are only 3.5 inches thick, but it is probably typically thicker than your plywood sheets. So you do want to be aware of that. So, okay, and let's just look at this toolpath really quick. So I'm using a pocketing toolpath. My cut depth is 0.75 inches, which is the thickness of the plywood. Those are what I'm using for the front and side stretchers. Just using the 1/4 inch down spiral bit, the white side that comes in our starter kit. You can really use whatever router bit you prefer. Let's see, let's look at these settings for a second. Here I have, so 2 flute, the pass depth is 0.1875. You could probably push that a little bit farther because this is probably a softer material, but if you want to take it easy, no problem. The spindle speed is 20,000 RPM and the feed rate is 200. I probably would actually run this a little bit faster, but I've set these kind of medium conservative settings, so you should be pretty comfortable even if you're new to running at these speeds. We do want to take note of the chip load calculator now built into Vcarve, and that is super helpful. So do check out the how that might change as we adjust these feeds and speeds. So, and with a softwood, it's really not as important as it is with aluminum, say for example, but is still something you want to keep an eye on as you're cutting and you're making those chips, and you want chips and not dust, right? So we'll say okay, and also be really thoughtful about your naming convention for these toolpaths. This is called pocket _ 0.75 inches deep. So I really know how deep the pocket is going. And then I also list the router bit, which is a 1/2 inch down spiral. So I'll hit calculate, and we'll just preview this. Awesome. So, it's a really simple operation, but, you just repeat this quick 6 times for the different legs. And it's a really simple part to just screw together because your plywood strips should just fit right in there. You might want to adjust a little bit for the tolerance of those, the width of those particular pieces. So let's look over here. Here is this is a 4x8 sheet. I'll open my job setup. So we have 48 inches, 96, 3/4 inch thick. If you want your top to be at a different material, that's fine. If you want it to be a little bit thicker, like I have the 1 inch MDF here, which is super heavy. But if you're using a sheet of plywood anyway, that's okay. So we'll say okay. And then I did a similar thing here in terms of the layers here. So I have my side stretchers and my front and back stretchers, which are slightly different dimensions. They're the same width and thickness, but they're different lengths because the front and back stretchers go all the way from edge to edge versus the side stretchers are inset a little bit because of the front and back stretchers. And then here we have the top dimension, which is obviously you can adjust that as you need to for different workbench sizes. I have this little hole here for the sensor cables to go through, as well as for my my AutoZ touch plate cable to pass through as well. So I can kind of pull it in and out. Actually, it would be cool to have it on a retract, but I find that it just slips right back in as I pull out for when I need it and kind of put it back when I don't, and it seems to work really well. Okay. One other thing I wanted to show you in this toolpath is this is just a simple through cut. I used a 1/4 inch end mill for this one just to save space between those parts that are being tabbed together. I kind of did this zigzag lattice with the tabs here, and then made sure that these tabs kind of formed a bridge, because toolpath doesn't necessarily recognize the location of a tab from one vector to another vector, even within the same toolpath. So it'll just cut right through a tab from a previous toolpath. The other thing here I wanted to show you is down here is the vector selection tool. So if you don't know about this already, I could go and manually select all these different vectors, or I could use this vector selection here with this pop-up. I want to look at the options I have here and say associate with toolpath, right? Because I want this vector selection to associate it with the toolpath. And then I will select the layers that I would like it to select those from. So the side stretchers, front and back and top, we'll hit close and calculate. So now whenever I move a vector, it will, recalculate based on that selection. See? I actually want to move that back there and recalculate again, right? So I find that to be a very helpful aspect there. So those are the Vcarve files if you choose to use Vcarve as your primary CAD/CAM tool. Awesome. Let me just check over here to see what's in the chat here. Hey Roger, good to see you. Okay, awesome. Oh, someone's ordered a Benchtop Pro. Yeah, I hope that this can work for you. If the legs are too long, let's talk about this for a second actually. These are 30-inch legs, but say for example you have the 2x2. What I did was to machine one end here of the leg and then rotate the leg, reference this corner and do that pocket. So it's a very simple operation. If you have a clamp set up already, it's really easy to flip that around, run a different pocket file. You don't even have to re-zero, you just reorient the part because it's the same dimensions on both sides as long as you have something, a square edge to reference for that piece to kind of butt up against. That works really well. So cool, awesome. I hope you find that useful. So let's just go and review one more time the I had that PDF I think pulled up for you here. Let's see. Right, so I'll just zip through this because I really love Fusion for designing, and I really love Vectric for designing too. But when you're working in something in 3 dimensions and are really thinking about the different kinds of joinery, I like to kind of pick and choose what works for me for a certain task that I'm trying to accomplish, right? And I want you to, if you're using different kinds of programs, use them, leverage them in the way that is the most efficient, that's really lends well to your creative thought process. I think Fusion is a really great way to kind of prototype, to get those designs out there. But you can see how simple these Vcarve files are to actually cut the parts. So I do like to lean on Vcarve for that, that CAM aspect versus having to do a bunch of setup in Fusion for Fusion CAM. This drawing workspace is awesome and I think very helpful, especially for fabrication shops where you're trying to pass on very specific information. So I do encourage you to check that out as well. Here I was able to make a parts list, illustrate all the different components here, explain those different dimensions as you're trying to assemble it, or if you're trying to figure out some tricky joinery. Having these images, print out references. I know that a lot of us are working in the digital world, creating these designs, creating our CAD and CAM, but having that printout in the shop when you're working with the physical materials, nothing can really replace that, right? So do consider this tool and how that might lend well to your workflow. So, so the Fusion360 updates, yeah, definitely something to consider, right? So Fusion360 still does have a personal license available, and that will always be free. They did add a few features that are now paid features, which are definitely inconvenient, but I don't think it's inconvenient so much as to bother a hobbyist, because those were definitely meant to hinder a production shop, as you know, they were trying to make this product that is serving production fabrication industry versus, but also really want to support makers who are, you know, hobbyists and who are doing this, you know, for fun. So you could definitely do this still in Fusion, especially the CAD aspect. There's a few things in CAM, you know, that we can get into in a future conversation, but you will still be able to accomplish all the CAM you need to for this project in Fusion's personal license. So you should not have any issues with actually producing it. There's, you know, I think there's rapid feed rates or something that is more important in a production than this particular project. So definitely something to think about. Or, you know, I just used the Vcarve Pro for this CAM and used Fusion CAD because the Fusion CAD wasn't hindered for me in the personal license. Yeah, the side stretchers here, right? These are just super simple parts. I like the illustrations of understanding how those kind of fit together. Yeah, great. I'm glad that helped. Awesome. I try to, you know, it's great to be able to put these different kinds of notes on how, what the options might be. So if you're making a file for other people, what are those options? So as I was mentioning before, I kind of just put my cables between these two legs, but you could put them, sandwich them between these two panels as well, which is a super nice way to just kind of tuck those away. No one wants cables on the floor as well. Yeah, and here's those shelves. So let me know if you guys have any last second questions here. Like to try rounded blind joints instead of all square. Yeah, awesome. Definitely so many cool different kinds of joint area you can do. This is a super simple one, and I wanted to keep it down to very simple operations for the leg fabrication here, because really the most difficult part to make is the legs, right? And then if you just zoom in on that particular part, it's not all that complicated, right? So let's see, I'll just show you guys this render again. I really hope you enjoyed this project, and let me know if you build it. If you do, please feel free to share that with us. You know, on Instagram at AvidCNC. I'd be really happy to see it and see it implemented in your workspace. We're looking forward to future live streams. We're now doing a Wednesday Instagram live stream, Wednesdays noon Pacific time, where we're interviewing different customers and collaborators to hear their story about their projects and everything that they're doing. So please tune in, and you know, if you're interested in sharing your story and your shop, giving us a little shop tour, please reach out, and we'd love to have you on the show. So awesome. Thanks, everybody. And we will, let's see, where is it? I'll see you guys next time. Bye.